So in our last video, we found that the force total in the y direction was going 4 pounds downward, and the force total in the x direction was going 3 pounds to the left. Now, we know that these forces will combine to go in the downward and leftward direction, making some resultant force, which I'll just label RF. So the question is, what is RF? That is, what is the magnitude, and of course, what is the direction? So I'll label the direction as theta, the Greek letter theta, which coincidentally looks nothing like a T. And of course, you might ask, well, what is theta? Well, it's going to be the angle that it goes off of the y-axis. The y-axis here, here's the angle, and here is theta. So how to calculate both? Well, calculating both is really no different. Let me go ahead and make a starting point. It's no different or no more difficult than finding the amount, the hypotenuse, and the angle of a triangle. And of course, this is FTY, which is 4 pounds. And I'm just drawing this over here so I can have everything starting from the same point. So then I'll draw FTX. I can get the right tool out, going out this way. And of course, since FTX is a little bit smaller than FTY, I should draw it a little bit smaller, right? It's 3 pounds. And the resultant force will go just as far down and just as far to the left as the two. And now we basically have our triangle. And you might say, well, what triangle, Mr. Anderson? These are all coming from the same place. That's not how a triangle works. Well, we can sort of translate FTX down here. And we can sort of draw it, and I'll draw it as a dotted line to kind of give you the idea that it's not exactly it, but it is it. And then, of course, we have our angle theta here. And by strategically placing one force on the tip of another, we have a triangle to work with. So we can find both our magnitude and our direction. So let's start with the direction, for example. So we've got theta. Well, theta is equal to what? Well, let's see. Well, we're dealing with the opposite and the adjacent sides. We don't know the hypotenuse. Well, that's tangent. And since we're looking for the angle, that's inverse tangent. Excuse me. Well, the inverse tangent is opposite over adjacent, so we're going to multiply the inverse tangent by the opposite over the adjacent. Well, the opposite is 3 pounds, and the adjacent is 4 pounds. And so we just plug this into our handy-dandy calculator. We pull it out, we get our inverse tangent, and we just say 3 over 4. And we get our angle, if I can hit the 4 button, we get our angle is 36.9 degrees. So equals 36.9. And I can rewrite it down here as well, equals 36.9 degrees. And of course, this is coming off the y-axis, and it's going down and to the left. And now all we have left is finding the hypotenuse, or the resultant force, which in this case, our triangle would be the hypotenuse. Well, there's several ways to do it. You could sine, cosine, tangent with our angle, but I'm going to use the most simple way, and that's a squared plus b squared equals c squared. Well, a is clearly 3, so we use 3 squared plus b squared, which in this case is 4, so 4 squared, equals c squared. And in this case, c squared is our reactionary force. So we can rewrite this equation. 3 squared becomes 9, 9 plus 4 squared becomes 16, so 9 plus 16 equals RF squared. And of course, 9 plus 16 is 25, so 25 equals RF squared. And then we just got to take the square root of both sides. So square root symbol. And we get a final answer of 5. 5 pounds of force. So we can rewrite it over here. RF equals 5 pounds. And it's going 36.9 degrees down and to the left off the y-axis. So as you can see, calculating force vectors is really no different than calculating triangles or any other type of vector. You just basically replace feet with pounds.